All right, so here we go. We're going to go ahead and get started with number 7 since that's where we left off. This one is solving our beautiful system of our beautiful equations. Notice here that we have two equations. One equation is 2x plus 5, which is a beautiful linear equation. Whenever we have an exponent higher or the highest exponent that we have here is of 1. Notice here, for example, here, power of 1. That means that we have a linear equation. We're going to have a line. So in order for us to graph that beautiful line, if you guys recall, we have our equation y equals mx plus b, where m is our beautiful slope and b is our beautiful, no, backwards. Yeah, y-intercept. I was right. Y-intercept. Sorry, guys. My mind's not here. So we're going to go ahead and use those items to help us graph the beautiful line, y equals 2x plus 5. My y-intercept, I also like to refer to it as my starting point since it's going to help us start. And then from there, we can go ahead and proceed with the slope and graph the rest of the parts. So here is my beautiful point, y-intercept at 5. So that means that my y-axis, I'm going to have an intercept at positive 5. So I'm going to go ahead and graph it. Next item, my beautiful slope is going to determine how am I going to go on to the next step. So my slope here, m equals beautiful 2. If it doesn't have a denominator, we are automatically writing underneath 1. So therefore, my next step, it's rise over run. So my rise is 1, 2, and over 1. We always go to the right. Yes. No study guide. There's one on my desk. Can you get a study guide? Study that. All right, next point. Up 2 over 1 to the right. Up 2 over 1, and we're out of the graph. Now, if we need to continue with the opposite direction, we're going to go down 2 and to the left 1. We're going opposite. So remember that we have to keep the same trajectory of that beautiful line. And we are able to plot the next beautiful point. Look at that. Beautiful. Okay, now go ahead and grab your beautiful straight edge. I have mine. And connect your beautiful values. Nice and beautifully done. If you don't have a straight edge, use anything that you guys have straight. For example, your notebook, binder, anything. A straight edge. All right, that's how we graph a linear equation. Anything that looks like a line, anything with an exponent of 1. Now, anything with an exponent of 2 should look like a what? Start with the B. A parabola. Thank you, guys. Okay, so we're going to go ahead and graph our next point. We can either, 1, choose a domain from -2 to +2, and then substitute my points and see what my values are. Or 3, we can use the transformation that we have here, figure out what my H and K are in order for me to identify my vertex, and then from there, graph the following points. There's several ways to do it. I'm going to go ahead and do both, okay? So my first item, I'm going to go ahead and create my table. This is to graph the second equation, y equals, let me go ahead and graph this one in a different color so you guys can see it. I'm going to do it in green. Here's my green. So y equals x plus 3 squared minus 4. And I'm going to create a beautiful table, bless you, with the domain, meaning that my x values are -2, -1, 0, 1, and 2. And if we need to continue on and more, then we'll go ahead and add more values so we can go ahead and see where the other parts are. Now, my interest here is to see where exactly they intersect. Those are called the solutions, okay? I want to see where they intersect. And hopefully there's going to be 2, 3, no, not 3, 2, 1, or none. All right, here are my y values. So let's go ahead and figure out when x equals -2. Let's go ahead and substitute -2. I'm going to do my work here. Y equals -2 plus 3 squared minus 4. Negative 2 plus 3. 1 squared. 1 minus 4. Negative 3. So whenever y is -2, sorry, my x is -2, my y is -3. So let's go ahead and plot that point. At -2, it is -3. Next value, we have y equals -1 plus 3 squared minus 4. -1 plus 3 is 2. 2 squared is 4. 4 minus 4 is 0. So this one is 0. So at -1, it's beautiful 0. A ver, let's try 0. So 0 plus 3 squared minus 4. 0 plus 3 squared minus 4 is, let's see, 0 plus 3 is 3. Squared is 9 minus 4. Beautiful 5. Let's go ahead and write that out. +5. So at 0, it is +5. Do you guys see a beautiful solution happening? Yes, we already have 1. And let's see, let's go one more. Let's try for 1. Y equals, let's see, 1 plus 3 squared minus 4. This is 4. Squared 16 minus 4. Beautiful 12. So this one's going to be outside of the graph. Let's say 11 and 12. It's going to be somewhere out here. So if I continue to go on and on and on and on, I'm going to continue to have higher numbers. This is +12. I'm going to graph the trajectory that I have so far. It goes down here. And then I'm missing one more point or so over here. So I chose my domain to start at -2. I can go and continue more on the left side to see if there's any values that are intersecting that beautiful equation on this side. So instead of writing, I'm not going to use 2. I'm going to use what? I want to go more negative. So I'm going to use -3 next. So y equals -3 plus 3 squared minus 4. So -3 plus 3, 0. Squared, 0 minus 4, -4. So whenever it's -3, my beautiful y value is -4. So let's go ahead and say -3, -4. I'm looking at this. -3, -4. Did I graph it wrong? Yes, I did. -3, -4. Down here. There you go. So this continues to go down and down. Okay, let's go ahead and do one more. Let's go ahead and try -4. So let's try y equals -4 plus 3 squared minus 4. This would be -1. -1 squared is 1 minus 4. -3 again. So it's going up now. So whenever my beautiful value is at -4, it's now back at -3. So -4, -3. Do we see another solution? Yes, we continue to go. Now, if you need to go another point on the left side of my beautiful graph, we continue with -5 and let's see where it intersects. So y equals -5 plus 3 squared minus 4. This case, we have 2. -2 squared is 4. 4 minus 4 is beautiful 0. So it's going to be up here. And we can see that it continues to go up and higher and higher. There you go. And that's graphing. So what's my solution here? It is what? D. It's -3, sorry, -4, -3, and 0, +5. So that is graphing. Again, your table never fails you guys. It always works. Graphing, we can go ahead and use either transformations. Like I said, we can go ahead and figure out where it goes, left and right, up or down. And then from there, decide where our beautiful original function goes, okay? So this is with using a table, transformations. If we wanted to graph the second graph, the quadratic graph, we could start with our beautiful vertex at 0, 0. And then our next value would be 1, 1, and then 2, 4, and so on and so forth. We can go ahead and transform each of the values according to the transformation that's happening. So this value right here inside with our x determines how we go left or right. This goes and determines how we go up or down. So it is the opposite value here. So it goes -3 to the, or it goes 3 to the left. And this determines whether we go up or down. Since it's negative, we're going to go down 4 spaces. So every single part right here, we can go over 3. 1, 2, 3, and down 4. 1, 2, 3, and 4. That's where we get this point. The next point, we can go ahead and transform it the same way, all the way through. 3 over, 4 down, 3 over, 4 down, and so on and so forth, and move all the points that way. If you guys want to do transformation, if you guys feel comfortable with the table, then create a table. I like to visualize everything and make sure that I have all my points where they're at. So I like to create my domain. I always start from -2 all the way to 2. And if I find out that I need more values, either on my left side or right side of my axis, then I add more values to see where they finish off. How I did towards the end of the graph. See how I needed more values over here? So I can see where it continues on. So I create more points. Let me save an image before I forget. That everybody has this. Because we didn't need to go further this way. On the x values, these are our x values, right? They're the values that are here. So I didn't need to go further to the right. I need to go further to the left. So I can see the rest of the graph on this side, on the left side. So that's why I said, no, okay, no more right side. I'm going to continue to the left. So from the left, I need to add or go more to the negative side. So from -2, I decided to go to -3, -4, -5, and so on and so forth until I see the next intersection happen. It depends on where your graph is located. So you're gonna have to play with your domain. On the final, I always start from -2 to 2 so you can see a glimpse of it. If you need to go further to the left, then you go further to the left. If you need to go further to the right, you go further to the right. So you add more values depending on where your intersection. Whenever we graphed from -2 to 2, I saw this intersection right here. I wasn't able to determine where the second intersection was. That's why I had to add more values. Okay. All right, those are all good questions. Let's move on. Okay, so this one is going to bring back my beautiful transformations. We're going to go ahead and have our beautiful general form. Whenever we have our general form, guys, we're going to go ahead and see all the parameters. So I'm going to only give you guys the 3 parameters that we focused on. We didn't touch much on parameter B, but we did see parameter H and K, and we did see A. So if you guys remember what they look like, we're going to have our beautiful f of x, and write this one down, guys. Equals our parameter A. This is multiplying to our beautiful x value on the outside. Inside, something is happening to my beautiful x, and I'm going to subtract the k value, sorry, the h value, and I'm going to add the beautiful k. Now, if we forgot what each parameter does, I'm going to go ahead and tell you. Whenever you have a beautiful a parameter, this one is going to stretch or compress. It's going to stretch or compress in the horizontal direction. So it's going to go woo, 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 okay? Now, this one that goes on next, the one that we call H, this one is going to move our parameter either left or right. Notice here that it's depending on what the x value is. So this one moves it left or right. Now, something that I want to tell you guys is that whenever we have this negative, it's always going to be the opposite value of it. So if you're given, for example, h equals positive 4, in here, it's going to say that it's negative 4, okay? If it's, let's say, negative 5, in here, it's going to say that it's positive 5. All right. Now, my last parameter that I have here is beautiful K, and K is as it's given. This one is going to move your beautiful graph up or down. Okay. Up or down. And it's actually a vertical stretch, not a horizontal stretch. It's only A. A is, I'm only going to give you guys A. B, don't worry about B. B is going to be given to you guys in pre-cap. So that's a whole different story. All right. Yes, that's a whole different story, guys. A, and they're going to be given to you guys as A, B, and C. Even though we use them as A, H, and K, they're going to be given to you as A, B, and C. I don't know why the text, every textbook changes it, but it's the same story. All right, let's continue, guys. We have our beautiful parent function. This time my parent function is x to the power of 3. Remember that x to the power of 3 is a beautiful graph that looks like this. Here's my beautiful parent function. We're going to go and transform that beautiful function according to the next parameters. We're going to go and stretch it vertically with a factor of beautiful 2. We're going to shift it 4 units to the left. And we're going to shift it 3 units down. So let's go ahead and see. Whenever we stretch vertically, we're going to go ahead and consider that one to be our parameter A. So in this case, A equals 2. If we move left or right, that parameter is going to be what? H. So therefore, it's moving to the left, So it's moving to the left 4. And whenever we move to the left, we go into the negative side. So here's left, negative. Here's right, positive. Now we're going to go and shift 3 units down. 3 units down is, if it goes up, it's positive. If it goes down, it's negative. So therefore, K equals what? -3. Okay, so we have our A, we have our H, and we have our K. So I'm going to go ahead and write my beautiful function. F of X equals A times X minus H. My beautiful parent function has a power of 3. So I'm going to go ahead and write my power of 3 plus K. Ahora sí, let's go ahead and substitute every single value. So f of x equals, what's my A? +2. X does not change, it stays the same. Minus, what's my H? -4 to the power of 3 plus what value? -3. All right, let's go ahead and simplify one more time. F of x equals 2. X minus -4, that becomes a +4, and power 3 minus beautiful 3. Which one has this beautiful equation written as? This one is number... Is it A, B, 0, D? In this case, it's D. ¿Qué pasó? The vertical stretch is the A. Yeah. So if you guys recall, let me go ahead and plot this really quick. On to the next one. Número 9. Which graph is an even graph? Is an even function with a positive leading coefficient. So if you guys recall, there's 4 type of graphs, 4 type of polynomial graphs that I taught you guys. And let me go ahead and create some space. Just so I can have it here. Wrong color. There you go. So here are my 4 types. Go ahead and write them down, copy them down, wherever you guys need to write them down in your beautiful study guide. I had my beautiful 4 types. So my first type, I had x to the power of an even number. So these are basically x to the power of 2, x to the power of 4, x to the power of 6, and so on and so forth, right? It is a positive coefficient, meaning that the number that's in front of it, no matter what number it is, if it's positive, it happens to have this following end behavior. Let me go ahead and construct my beautiful graphs. Here's my y-axis, here's my x-axis. Beautiful. Now, we said that if it's positive and even, my endpoints have to be both facing up and up. Up and up, like this. If it's positive. Remember that we had an x squared and it looked like a problem. And then we did the same with an even function with a negative sign as a leading coefficient. So I'm going to go ahead and do the next one. X to the power of an even, but with that negative leading coefficient. Again, my beautiful end behavior. My both extremes will not have to go down and down. So it's either up and up, down or down. It depends on what my beautiful leading coefficient is and the degree. So we're looking at those 2 things. So something happens in between, it crosses and intersects my beautiful x-axis so many times. And all we need to know is that my extremes, my end behaviors, they go up. My end behaviors, they both go down. What if they're swapped? We're going to do the next situation. So what if they were swapping around? So let's go ahead and say that I have an x to the power of an odd number. So this is any type of beautiful function with x to the power of 3, x to the power of 5, 7, and so on and so forth. Anything to the power of an odd number. If it has a positive leading coefficient, meaning that it's positive 1, positive 2, 3, 4, 5, does it not matter what it is? As long as it's positive, it's going to have the following end behavior. It's going to come from the bottom on the left side, and on the right side of my beautiful graph, it's going to go up. Now, we said that the same thing happens whenever it has a beautiful negative leading coefficient and with an odd, beautiful exponent. My beautiful endpoints, what happens? My end behaviors, they swap. So instead of going down from the left side, it goes up on the left side. And on the right side, it goes down. So let's see, which one are we looking for? We're looking for an even function with what? A positive leading coefficient. So we're looking for an example that fits this situation. We're looking for the 2 end behaviors to go up and up. Which one does it have that end behavior? Let's go ahead and see. A. Let me highlight my left and right side. So if I were to draw a beautiful line right underneath the y-axis, I can see my left side and my right side. So let's see, this one goes down and then on the right side, it goes up. Does it follow the same behavior? Up and up? No. Let's go ahead and do the same with the next example. This one, it goes up and on the right side, it goes down. Does it follow up and up? Nope. Let's go ahead and do B. And behavior, it goes up and up. Does it follow this behavior? Yes. Let's just try the last one. On the left side, it goes down. On the right side, it also goes down. Does it follow the up and up behavior? It does not. So it has to be B. So we're just looking at the end behaviors, at the ends. Which one follows this particular behavior? And again, look at the even. Even has to go up. Positive, even up. Negative, even down. Then we go on to the odd. On the left side, it always starts at the bottom. The right side has to be the opposite part. And then if it has a negative coefficient, it swaps. So keep that in mind. Study this part. Let me go ahead and clear. So we're going to go ahead and graph our beautiful graph, x to the power of 3 plus 6x squared plus 9. And we're going to go ahead and identify the beautiful domain and the intercepts that happen in the x-axis and also the y-axis, I guess. So let's go ahead and look at the highest degree, guys. What's the highest power in this situation? What is my highest degree in my function? Power of 3. So we should have how many intersections at least? 3 intersections, 3 solutions at the least. Now, so let's go ahead and solve. I'm going to go ahead and write it right here at the bottom or on the side. Let me go ahead and create some space so we can go ahead and solve. Let me write my beautiful equation down. I have f of x equals x to the power of 3 plus 6x squared plus 9x. A ver, how can we solve this? We're going to make the beautiful right side equal to 0. So I'm going to rewrite it, x to the power of 3 plus 6x squared plus 9x equals 0. Let's go ahead and see if we can factor it. What do you guys see in common? The what? The x's. So let's go ahead and factor that one out. X. We're left with x squared plus 6x plus 9 equals 0. Can we continue to factor? We have an x to the power of 2 plus 6x plus 9. We're going to go and use what method? Power Ranger. Let's go ahead and use that one. Two numbers that multiply to 9 and add up to 6. It's going to be 3 and 3. So let's go ahead and write my beautiful factors. I have x plus 3, and x plus beautiful 3 equals 0. So I have my 3 factors. My first one, I'm going to make it equal to 0. The second one, I'm also going to make it equal to 0. And the third one, I'm also going to make it equal to 0. So I have x equals 0. This one's already solved. The next one, x equals -3. You can do your one-step equation, subtract 3. And the same happens with the other one. X equals -3. So my solutions are x equals 0, -3, and -3. So from when we were learning these beautiful polynomial equations, we said that whenever it repeats a 0, it's going to be called a multiplicity. Whenever we have a multiplicity, whenever it touches that 0, it's going to bounce back. It's going to have that bouncing back pattern or behavior. So let's go ahead and look at our options. Let's do the first one. We have a 0 and -3 and a 0 at 0. Now, we said that whenever we have a multiplicity, it's going to bounce back. So this one is going from the bottom. It touches -3 and it bounces back and it intersects 0. Now, next thing, we have to look at the degree. The degree is power of 3. 3 is a even or odd number? Odd number. So whenever it's odd number, what's the end behavior like? From the left side, it should come from the bottom. So it should be down. On the right side, it should go up. So does this one go from the bottom? Does it go to the bottom on the left side and it goes up? Yes, it does. So far, A is looking like a winner. Let's go ahead and analyze the rest of them. Let's analyze C. C, my 0 is at 3, -3 and 0. However, we have a multiplicity at -3. Is it bouncing back? Does it have a bounce back? No, so C is not an option. It has to bounce back. A ver, let me see the next one since I can't see them on my screen. I want to save an image. Let me see. Let me erase all this mess. Let me see. A ver, let's see. My 0 is at -3 and at 0, yes. But my end behaviors, does it follow the positive leading coefficient and odd exponent? It goes on my left side, it goes up. On my right side, it goes down. Nope, this one does not because it goes up and then down. We want it down from the left side, up from the right side. And let's see the last one. D only has a 0 at 0. It's missing the 0 at -3. So my option has to be A. Any questions on this one? The paint is making me dizzy. I'm not kidding. I can smell it very strong. Okay, how many more do we have? They go fast. A ver, the next one. How many zeros are we going to have on this one? P of x equals x minus 1 times x plus 1 times x minus 4. Why 3? There's 3 factors there on our beautiful polynomial that's given. Even though it's not multiplied, not distributed, it's actually already solved for you guys, or it's actually already factored for you. All you have to do is find the zeros. So in order for us to find the zeros, let's go ahead and make each factor equal to 0. So we're going to make P of x equal to 0. So we're going to make each of these factors equal to 0. Okay, so let's make the first one x minus 1 equal to 0, x plus 1 equal to 0, and the last one x minus 4. Minus 4 equal to 0. All right, what's the solution to the first one? X equals positive 1. The next one, x equals -1. And the last one, x equals positive 4. So let's go ahead and see from our beautiful graphs which one has those 3 zeros. Let's try the first one. Let's see, we're looking at positive 4. Yeah, it smells like paint jokes. So -1 and positive 1. Go ahead, take a bus. The first one has a 0 at -4, -1, and 1. Is this one an option? No. Next one. -1, positive 1, and positive 4. This one might be an option. Let's go ahead and put a question mark. The next one. -1, positive 1, and positive 4. Another option. The next one, -4, -1, and positive 1. No. So we have beautiful, is it C and B, that are possible options. Now we have to determine, again, the leading coefficient. What do you guys think the leading coefficient is going to be here? Positive or negative? Whenever it's negative, it has a negative sign outside. Is there a negative sign outside? No, so this one has to be positive. So it has to follow along with the beautiful behavior of an x to odd number, because we have 3 factors, meaning that we have x times x times x to the power of 3, and with the positive leading coefficient. So therefore, on my left side, it's going to go down. On my right side, it's going to go up. So which one has that behavior? On the left side, it goes down, and then on the right side, it goes up. So which one is it, B or C? B in this case, so it has to be B. So again, those 4 examples, they have to be part of your beautiful study guide. Okay, so make sure you guys study those. Let's go ahead and move on. A ver. Now we had to find the zeros. Now we have to go backwards. We have to find, we are given the graph. Now we have to find what the zeros are, what the possible function should be or could be. Okay, so let's go ahead and look at the zeros. Let's look at the graph. Again, the zeros is wherever it intersects the x-axis. So it has one intersection here, another intersection here, and the last intersection here. So it has x equals -1, x equals +2, and x equals +5. Right? Yeah. Okay. Now, remember that each one of these, we're going to make now the right side equal to 0. We're going backwards. So we're going to go and do the inverse operations. So instead of having -1, we're going to add 1 to both sides. So this factor will now be x plus 1. This factor will be x minus 2. And the last factor, I have to subtract 5 on both sides, will be x minus 5. Now, this is where I want you guys to be very careful. Do you guys see any bouncings? Where? In which 0? Bouncing means that it touches the axis and then it bounces back up. Where is it? On -1. That means that that 0 is repeating. So instead of having only 1, we're going to have another one of those. So instead of having x equals -1, we're going to have x plus 1, repeating once, repeating twice, and the other zeros. These intersect, meaning that it goes through, it doesn't touch it and then bounce back. Okay? Any bouncing means that it repeats. Okay? So we're going to go and write our beautiful, let's see, p of x equals x plus 1, x plus 1, and x minus 2, and x minus 5. Whenever we don't write these out, we can go ahead and write them as one single factor to the power of 2, meaning that we have that one repeated that many times. So which one follows this beautiful function? It's D, and D is not showing on my screen. Let me see. Yeah, it is D. D in this case. So just be careful, guys. Observe the behavior. Another hint would be also look at the end behavior. Where do my ends end up? Up and up. So therefore, up and up has to be x to the power of a even number with the positive leading coefficient. So I have to have 1, 2, 3, and 4. I have to have an even amount of factors. All right, clear. What about number 13? I bet. Can you guys do number 13? Or are my zeros? -2 and +1. X equals -2 and x equals +1. Do we see any bounce backs? On +1, which means that that one is going to be repeated. We have both 2 of them. So this is going to do the inverse operation. So we're going to go ahead and add, subtract, subtract. We have x plus 2, x minus 1, x minus 1. This is our beautiful f of x. That's our function. That's what we label it. So therefore, we have a beautiful function of x plus 2, x minus 1 times x minus 1. Which one's this option? It's beautiful D. Yay. So we have, again, we have one intersection, right? Here, it goes through. We have a bounce back here. A bounce back is when it touches that point and it goes back up. Or when it touches it from the bottom and it bounces back down. It has like a boomerang type of trajectory. I used to call it my boomerang. Whenever it boomerangs, it goes and it comes back. All right, safe. Clear. Go ahead. All right, let's go ahead and move my beautiful parent function. We have it at x to the power of 2. We're going to go ahead and give it to us, transform with our functions, g of x. Did you need more time to copy the other one down? No, okay. g of x equals x minus 4 squared minus 3. So very similar, guys, how we had our beautiful transformations. We had our g of x equals a, x minus h plus k. This time my parent function is to the power of 2. So this is going to have a power of 2. Now, let's go ahead and compare and contrast. G of x equals a, x minus h squared plus k. I'm going to go and write my other g of x. G of x equals, let's see, there's no a, but I do have a minus 4 squared minus 3. That it's given right here at the bottom. All right, so my parent function is drawn right here. This is where my beautiful vertex is. This bottom point, it's at 0, 0. We're going to go ahead and move it according to what my beautiful parameters are here that I'm going to move them. Only h and k are present, so let's go ahead and determine. My first parameter that I have here happens to be h. Let me go ahead and identify it. Which one are we talking about, Ms. Vasquez? This one right here. Do you guys see it? It says that negative h equals negative 4. So let's go ahead and write that down. Negative h equals negative 4. Can we isolate that beautiful h? Yes, let's go ahead and divide by that negative 1. Negative 1. H equals positive 4. Now, if you guys remember my parameter h, what does it do to my graphs? I move them what? Left or right? So because it's positive 4, I'm going to move to the right. So I'm going to move 1, 2, 3, and 4. All right, so here it is according to that parameter. My next parameter is parameter k. So let me go ahead and identify parameter k. K in this case is negative 3. So let me write that down. K equals negative 3. Is k isolated? Yes. And k moves my beautiful graph up or down. So it is negative 3, so I'm going to go down. There you go. So from here, I go down how many steps? 1, 2, and 3. So what is the coordinate of this beautiful graph? 4, negative 3. 4, negative 3, thank you. Let me go and save an image. Which one fits that model, guys? It moved to my beautiful right 4 steps, and it went down 3. You guys have your beautiful graphs. I can't see them because I'm going to move the work. Is it A? Yep. It is A. Let me clear all this, guys, or let me move down a little bit so you guys can see it. So again, we had to move to the right 1, 2, 3, 4 spaces, and down 3. Here. In this case, from here, we go to the right 4 and down beautiful 3. And that's where we have 4, negative 3 as our beautiful vertex. H and K, H and K. All right. How do you feel about all these? You guys ready? Yeah. You guys are? Let me see. Do we have time? Let me see. The next one we have number 15. We're going to solve the polynomial. The next one we have roots. The next one we have more complex roots. And then the last one we have to solve the polynomial using the roots. So what I'm going to do is that I'm going to go ahead and go over the last, is it 4 of them tomorrow. I'm going to start the final on Wednesday. Yeah, that seems like a plan? Yeah. Okay.